64 and 65. On the diagram below, we have a wave and a rope, and they want us to determine the wavelength of the wave and the amplitude of the wave. So, for the wavelength, we know this whole thing is 8 meters, but it contains more than one wavelength, right? So, one wavelength would go from here, it goes up to a maximum, down through a 0 point, a minimum, and then back up to where it started. That's a classic sine curve, right? So that's one wavelength, and then it does that again as it goes to here, and then it starts to do another one, but it doesn't get all the way through, it only gets halfway through. So we got 1, 2, and a half. So there's 2.5 wavelengths here, and there's 8 total meters of wave. So to answer 64, one wavelength is 8 meters divided by 2.5 waves, right? So that is, if you put that in your calculator, you'll find out that equals 3.2 meters per wavelength. So this is 3.2 meters. The next one, determine the amplitude of the wave. It's tempting to put 1.2 here, but you have to remember the amplitude is only the distance between the reference position, the 0 position, and the peak. So, and then again here, right, it's in the trough, so the crest in the trough. And in each of those cases, it's half of that distance, so it's actually only 0.6. So the amplitude is 0.6 meters, and that's it.